All right, so we're going to be talking about graphing exponential functions. Hopefully, this is something you've already looked at. It's just been a while since you've done it, so more of a refresher. And then we're going to talk about shifting them up, down, left, and right, so horizontally and vertically. All right, we'll talk about that in the second part of class. So let's look at one together here. F of x equals 1/4, all of that raised to the power x. All right. Now, when I look at that, my brain immediately thinks that it should look like one of these. Which one is it going to look like? Growth or decay? No. Decay. Why is it going to look like decay? How do I know that this one, the one we're doing right now, is going to look like decay? If you look in the parentheses, what is 1/4 as a decimal? 0.25 to the power of x. If this number in the parentheses is between 0 and 1, it will be exponential decay. Yes, if this number in the parentheses is between 0 and 1, it will be exponential decay. All right, if the number is greater than 1, it will be exponential growth.
So if it's like -2, would it ever be negative?
It'll never be negative. It'll always be positive. Greater than 0.
So it's just if it's less than 1.
Yes, so let's think back to yesterday. Remember, yesterday for growth, we used 1 plus r. All right, if our growth rate is in between 0 and 1 as well, like 1 plus 0.1 is going to be 1.1. That's greater than 1, so that's why it's growth. If we use subtraction, and our rate of decline, let's say, is 5%, 1 minus 5% would be 0.95, which is between 0 and 1. 5% is 0.05. Okay, so 1 minus, I'm just making these up. I'm just showing you that that's how I know which one is which for growth and decay. Okay.
Which if it's greater than 1 is
Growth. It'll look like this. If it's greater than 1, it'll look like this. If it's less than, in between 0 and 1, it'll look like that for decay. All right, so let's try this one. Let's make a T-chart. I know, it's really difficult to draw 2 lines and then the letter X and Y. I mean, my 3-year-old son could get close to attempting this. I know, you're older than that. That's my point. Okay. Just a few more days. Okay. Let's think about values we could plug in for X. If you take a look up there, I could plug in 1, sure. You could plug in 2, but you're probably not going to end up using it, but we'll plug it in if you like. I don't really want to plug in fractions and decimals. Definitely want to plug in 0. No, plug in anything you want.
-1,
-1.
-2.
Let's start there, but you're going to find out we're not going to use all those points. This is where if you have a calculator, it'll be very helpful. So what I've taught you in the past, if you have a yellow calculator, is to turn it on and click the button that says, I think it says table or tablet. If you click table, it should say y equals, and you want you to enter the function. So do that, and I want you to put parentheses and click n over d.
1/4.
For Bashir. Oh, Bashir knows he can move. Who's cold? Oh, look at this desk right here. Perfect. What a beautiful desk. All right. Type in the function. You can type in the fraction 1/4 or use 0.25. And make sure that you put your variable x in the exponent. And then hit enter. I think it asks for you to like where to start. Does it say like where to start? Yeah. I always just put start at 0. The step is 1, and then just hit enter. You're so confused? Hit table, type in the function, and it will give you the XY T-chart. I always start at 0, but it doesn't matter, Gilberto. You're just going to have to like scroll up and down. Doesn't matter. Nope. As long as your step is 1, that's the most important thing. Where it says step should be 1. Maybe. It doesn't matter. You're just going to scroll up and down on your table. All right. So what happens when you have -2 for your x? It's 16. Now let's think of something's wrong there. For -2? So let's think about why this is 16. If you have 1/4 to the -2nd power, do you know what you should do to this fraction when you have a negative exponent? You should use, it's called the reciprocal. Flip it. So it'll be 4/1 squared, which is 16. So that's what the calculator did. What about for a -1 then? 4. 0, anything to the 0 power is 1. And then to the first power is 1/4 or 0.25. Same thing, don't care whichever one you want to write. And finally, squared then would be, which is, what is that? That is the fraction. It's 1/16. Very good. All right, if you're having trouble with this, I'll walk around later and help you individually. Lexi. Now we're going to graph it. So let's graph it. Now you'll notice I only plotted 3 points. Excuse me, Chris. I only plotted 3 points. But how many points did we have?
4.
We had 5, I believe.
Oh, yeah.
Yes, it's okay. There's no 16. All right. I guess I could plot the other one. Right there. You can check Mr. Mendez's desk for anything. Now, you should see that this is going to be decay. And what do you notice as we're getting to these points? We're getting closer and closer to what? To 0, the x-axis. All right? But we'll never actually touch it. If you went in your calculator and looked at when x equals 3, x equals 4, x equals 5, you'll see that we are approaching 0. We're never going to touch it, which, Dino, you're right. That's because it's an asymptote. Didn't seem like you were being very serious there, Lexi. How fun. How fun. The Voice? Great show. All right, so any questions on graphing this? I think if you are... Okay. Yeah, I mean, I wasn't done, but, whatever. It's not like my first year of teaching or anything. Let's do the domain then. What's the domain? What x values can you use for this function?
1, 2, 0, -1, and -2.
And what else?
Here.
What else?
Right.
Okay, what else? You should know where we're going here. Any number would work. So that means I'm going to write negative infinity, comma, positive infinity.
Is this example 1?
Yes, it is. Okay. Say it again. Because negative numbers are less than positive numbers.
Mr. Bennett, the domain is like where the line or where the line ends?
It's actually the x values. So I know you can see this one's pretty obvious. It's going to the right forever. So I'm going to approach positive infinity in the x direction. This one on the left is a little bit more challenging because even though it looks like it could curve this way, it's not. It's going to keep going that way. So it's going to keep slowly going this way. It's all about your x values for domain. Let's talk about the range. What are the y values of this function? Very good. Is 0 included?
No.
Do we touch 0? No. So when I write 0, I'm going to use a parenthesis because it's not included. We're not touching it. If it were been to include it, what would this be if it was to be included? It'd be a bracket, but we're not using a bracket because it's not touching 0. All right?
But why do we have a
Yes, student?
parentheses and a negative?
Well, infinities, positive and negative, are always parentheses. Infinities, parentheses.
So if there wasn't, wait, but our domain was.
Domain is going to be this, yeah. And then I heard, Dina, you say as long as it's above 0, so we're going to positive infinity. This arrow is going to positive. Infinities are always parentheses. Infinities are always parentheses. Any question on domain or range? I guess we'll see. I think you probably can tell. We're not going to use brackets.
I keep tripping myself up. Is domain just X or is that X and Y?
Domain is just X and range is Y.
Okay.
Right. For the domain? Well, so domain is just what are your X values? And if you look, the X values here, we're going to the right forever. And we're going to the left forever. Even though this arrow looks like it's kind of like stalling, it's going to keep slowly creeping to the left, which is this direction. So if you look at your table, another way to look at it is if you scroll up and down in your table, you'll never stop scrolling. You can plug in any X value and you'll get something. For the range, you'll notice if you were to scroll, I believe if you scroll up, if you scroll 1, 2, 3 for your X values, these Y values will get smaller and smaller, but they'll never touch 0. So that's why for the range, your lowest value is 0.000000000 right until you hit something. It's not 0. Now the last thing, the horizontal asymptote. You just said it, Lexi. Y equals 0 is correct. All right, we never touch 0, so y equals 0 is the horizontal asymptote.
Are you gonna have any vertical ones?
We're not going to have any vertical ones. Good question. Bless you. Any questions on graphing and then looking at domain, range, and the asymptote? Say it again.